Mann-Whitney U Test. Mann-Whitney U Test is non-parametric test, which is very close to independent t-test, which is involved comparison between two independent groups. Mann-Whitney U Test is used for ordinal type of data, or for interval or ratio of data that are changed or transformed into ranks. So the uses of Mann-Whitney U Test include testing two independent groups if the data are in ordinal format or if the data are not normally distributed. Let's explain the process of calculation of Mann-Whitney U Test through example. Let's assume we are testing the customer satisfaction in two different retail outlets, A and B. And let's assume the study conducted and the results appear in this table. We look at both of the groups and we start ranking them from the lowest to highest, given the lower value rank number 1 and next number 2 and so on. We look at the lowest reading in both of the groups, which is here 59, and we assign 1. The second reading is 62, so we assign rank 2. The third is 66, so we assign 3. Then 67, so we assign 4. Then 71, and we assign 5. Then 75, and we assign 6. And then 76, and we assign 7. The next reading is 79. However, there are two cells carry this number, and they're supposed to have 8 and 9. In this case, we assign 8.5 for both of the readings. Then we start by 10, so we omit 8 and 9. And then we continue till filling all of the cells. We need then to calculate the sum of the ranks in one group only. It does not matter what group we select. The end result after plugging in the dedicated equations will be the same. So let's select group A and calculate the sum of all of the ranks in this group, so the total result will be 27. There are two equations that need to be solved. First, the U value as per this equation, and after getting the U value, it's plugged again in the second equation of Z value. We need to solve for U value in this equation where all variables are known. N1 is the number of readings in group 1, which is 6, and N2 is the number of readings in group 2, which is also 6. The sum of the ranks for the first group is calculated earlier as 27. Plugging the numbers in the equation will result in U value equal to 30. Then we need to use this value in calculating Z value. Recalling the Z equation and plugging all numbers as all are known, this would result in Z value equal to 1.92. For this test to be statistically significant with the confidence of 95%, then the calculated value has to be higher than 1.96. Since the calculated value is lower, so we cannot reject null hypothesis, which means we have to accept null hypothesis, saying that there is no difference between the two groups. Let's check now our previous assumption when we said that it does not matter which group you select for calculation of U and Z values. Recalling our previous ranks, and we will use now the sum of the ranks for the second group, and in this case it will be equal to 51. Solving U value under the consideration of the sum of the ranks for the second group, then U value will equal to 6. Solving Z value for the new U value will result in the same Z value but with a negative number. Please note that the new Z equation values are the same as the previous calculation, except U value. In first scenario, U value was 30, and in the second scenario, U value is 6. So for the first scenario, 30 minus 18 equal to 12. And in the second scenario, 6 minus 18 equal to minus 12, which explain the achievement of the same numbers, but with a minus sign. The absolute value is compared with the Z 95% confidence value, which is here is lower, so we accept the null hypothesis.